Hi, I'm Paul. We're doing Leetcode must know interview questions. Today's challenge is a linked list cycle. We're into the linked list section of the must know interview questions. I got to be careful how I read this. Given a variable called head, the head of a linked list, determine if the linked list has a cycle in it. There is a cycle in a linked list if there is some node in the list that can be reached again by continuously following the next pointer. Internally, pos, POS, position is used to denote the index of the node that tail's next pointer is connected to. This is not passed as a parameter, and honestly, I don't even see the relevance of it to solving the problem. Return true if there is a cycle in the linked list, otherwise return false. Okay, so like example 1 here has a cycle. These examples are too simple. What are the constraints? Number of the nodes is in the range 0 to 10 to the 4th. That is 10,000. Let's see, the value of the node, that's not really relevant either, but it can be between negative 10 to the 5th and 10 to the 5th, which is 100,000. Pos is either -1, meaning that the list ends after the last node, or a valid index in the linked list. Can you solve it using O1, i.e. constant memory? Yes. I mean, that's really the expected way to solve it. So let's look at this. It's ranked as easy. I mean, there is an easy solution to it that you wouldn't really want to do, and that is just every node, just like put it in a hash set, and if you get to the end of the list and every time you get to a node, you check and see if it's in the hash list. If it is in the hash list, then you're in a cycle. If you get to the end of the list and you haven't found a cycle, then it's return. What do we return here? We return true if there is a cycle. Then you return false. There's no cycle. That's not the expected way to do it. The expected way to do it is with a fast pointer, slow pointer. And to be honest, the fast pointer, slow pointer approach is not like super intuitive. I mean, it actually has a name like Floyd cycle finding algorithm. Floyd has multiple algorithms with his name on them, but you can't get your name attached to some super obvious algorithm. So the way it works, let me see if I can do this. Let's get something to write with. Let's start with that. All right, you're going to have let me get it here. Okay, yeah, you're going to have, let's say, it's a little hard to fit in there. That'll be the slow pointer, and we'll also put a fast pointer. So the fast pointer advances by 2 nodes every time. The slow pointer advances by 1. All right? So the fast pointer, currently pointing at 3, is going to move to 0. The slow pointer currently pointing at 3, is going to move to 2. And then we can erase those pointers. All right, next, the slow pointer will move from 2 to 0 right here. And we can erase it here. The fast pointer is going to move, and this does have a cycle, so it's going to move from -4 back around to 2. All right, let me get a yellow pen here. All right, that's where that is, and then erase it right here. Okay, fast pointer will move from 2 to -4 right here, and erase it over here. And the slow pointer will move from 0 to -4 and erase it over here. If the slow pointer and the fast pointer wind up in the same place before any of these pointers get to the end of the list, then there's a cycle. All right? I'm not going to offer a proof of that, but I'm still, confident nonetheless that it's going to work. So let's rearrange this a little bit and write some code for it. Move that. Up at the top here in the comments is what a list node looks like. It has an integer property for value. It has a list node, which is a pointer to the next node in the linked list, and then it has a constructor, which is it takes an int and assigns it to value, and then assigns the next pointer to null. Okay. So what do we need here? Okay. We need 2 pointers. These will be, they're called list nodes. Sorry. List node slow equals, and the head pointer, the pointer to the head of the linked list, is given to us as an input parameter. So we want to set that in that way, and we also want to set fast pointer in the same way. All right. We're going to loop as long as the fast pointer and the slow pointer are not equal to null, because if they are equal to null, it means we hit the end of the list. Is that made obvious here? Not exactly. I mean, the way they express it is that what do they call it? Pause is used to denote the index of the node that the tail's next pointer is connected to. Ooh. I wonder if that means that it's going to point to -1. Now I'm a little worried. So all right, POS equals -1. So that means this points to, maybe it doesn't point to null. Hang on a second. Is used to denote the index of the node. All right, you know what? I'm going to use -1. I mean, usually we use 1 and 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 1 No, it can't. No, you know what? I'm sorry. It can't. It can't be negative. It can't be -1 because the pointer up here is a list node, so it has to be null. Okay, so let's do this. While slow is not equal to null, and fast is not equal to null. I'm running out of space here. And fast dot next is not equal to null. Why are we doing that? That'll be more obvious in a second, probably. But as long as we haven't reached the end of the list, then we're going to start incrementing the pointers. So slow will equal slow dot next. Fast will equal fast dot next dot next. That's why we have to check if fast dot next equals null, because when we get down here and try to access fast dot next dot next, if fast dot next equals null, this is going to throw an exception. So we have to check for fast is not equal to null and fast dot next is not equal to null. All right. If any of those conditions becomes true, we have reached the end of the list and we can return false. There is no cycle. But if slow equals fast, then we're going to return true. There is a cycle. Now again, this is rated as easy. This is not, to me, as I said, it's not all that intuitive. I think it's probably rated easy because they expect that most people have seen it. I mean, it is easy if you just do it with a hash set, but if you do it with a hash set, you're going to be asked, if you can come up with another way to do it, like with ON space requirements. If you do it with a hash set, you're going to need, wait, what did I just say? You're going to be asked to do it with O of 1 space requirement. A hash set is O of N space requirement. And, I mean, it could make a big difference, I suppose. How many nodes can we get in here? 10,000? Yeah. So if you don't have to generate a hash set with 10,000 nodes, all right, that's a plus. I can't think of anything else to do here. So let's go ahead and try to run this. All right, that is accepted on the basic cases. Let's try to submit. That is, oh my gosh. That is, well, it beats 100%. We get 0 milliseconds. I suppose it's not really anything to boast about because it's the same time that everybody else got. I suppose there's a few outliers here, but by the time you get to 2 milliseconds, there's nobody left. Memory again beats 79.14. I suppose. Well, I don't know. There's not much difference here. I mean, I don't think there's enough difference to say that the people to the right of our solution used a hash set. Because I would expect that to be. I would expect that to have a much longer tail. But anyway, so that is the linked list cycle tests. It's very common. It's a very common interview question. Just use a fast pointer, slow pointer, and that's it. So I hope you enjoyed that. Please feel free to like, subscribe, comment, and see you next time.